Hello everyone, this is Ankush here. This is the fifth video from the graph series, and the question that we are going to solve today is building teams. So there are n peoples in a class and n friendships between them. Your task is to divide the peoples in two teams in such a way that no two peoples in a team are friends. You can freely choose the size of the team. Okay, so let's understand it with examples. So you have five peoples and there are three friendships. The friendship is between one and two, and the friendship is between one and three, and the friendship is between four and five. So there is team one and there is team two. So in team one, you can have one, and in team two, you cannot have two and three because if in team two you can have two and three and four and five, right? So suppose you take two, you cannot have two and three here because these are the friends. One, two, and three are the friends. So one, two, and three are in the has to be in the other team. Now be- between four and five, one of them can be in team one and one of them can be in team two. So one four there is one possibility that one is team one and two is team two and three is in team two and four is team one and five is in team two. So this is the one of the possible answer, right? So how could you do that? How could you do that? So you can do it. So this is the undirected graph, and you have to check the graph is bipartite or not. If it is bipartite, that yes, you can divide it. You can divide n peoples in two teams such that uh, no two peoples are friends. Now let's see what is bipartite graph, right? So I am not going into deep in the definition, and I just mentioned one of the characteristics of the bipartite graph, which help us to solve this question. The characteristic of the bipartite graph is no two adjacent node have same color, same color. Now, if you are going to color the graph, right? So no two adjacent node have the same color, such that if node one has a color of zero, then node two has to be color of one, and node five has to be color of one, right? And four has to be color of zero. And now you can see that you cannot color it. If you color it by zero, then it uh, does not follow the property that no two adjacent node have the same color. And if you color it with one, then you cannot have. So this graph is not bipartite. This graph is not bipartite. If it is not bipartite, then you are not able to form such streams, right? You are not able to form such streams. Now let me explain you how can you find out the graph is bipartite or not, right? If graph is bipartite or not. So by using DFS or BFS, we can easily find out the graph is bipartite or not. Let's see. So this is the corresponding adjacency list uh, of this graph. Now let's see how I do it by using DFS. So you try to color it, right? So you call DFS in node 1 with color of 0, right? Now next call goes on to DFF of 2, and you have to color it in color it different from the node 1. So you just uh, change the color to 1. Now graph now node 1 has a color of 1, node 2 has a color of 1, right? Now DFS call goes on 1, which is already colored, and the color of the node 1 is 0, and which is different from the color of 2. So now, so this is correct, right? This is correct. Now the second call goes on DFS of 3, right? DFS of 3 and DFS of 3 with a different color, right? With a different color, that is 0. So the DFS of 3, so the color of node 3 would be 0. Let me, yes, it is of 0. Now the next call goes on DFS of 4 with a different color. So the color of the node 4 would be 1, right? Perfect, right? Now the call goes on DFS of 4. Uh, right now 2 is already colored. Now 2 has a color of 1, right? 2 has a color of 1. Now, this condition falls here, right? The condition would be if you call DFS on 4 and DFS is call goes on DFS of 2, which is already colored with a 1, and 4 has a color of 1. Now, two adjacent nodes would not have the same color, but means the condition would be false, and this will return false, and this will return false, and this will return false, right? And this ultimately we will we get false, and this graph is not bipartite. Now, if it is not bipartite, right? If it is not bipartite, so we just print impossible. And if it is bipartite, right? If it is bipartite, we try to color it, and whatever the color with the corresponding node. And I must say that this is the team, right? So the color with the node with the color 1 is in the team 1, and the node with the color 2 is in the team 2, right? So this is how you can check the graph is bipartite or not by using DFS, and you can easily solve this question. Now let's see the code, how we can code it.
Now let's try to code it. We have n number of people and m friendship between them. Create their essential list. Like for int I is equals to 0, I less than n, I plus plus, int x, y, c in x, y, and let's make it 0 based indexing. It's a c of x dot stack y, adjacent c of y dot pushback x. Perfect. Next, we have to create a color vector, initialize it with 1. Let's do DFS. If not, if color of I is equals to minus 1, then what we have to do? We have to call DFS. Bool DFS is equals to bool answer is equals to DFS of I, comma. Let's say we give it color. We color it with 1, and we pass color and adjacent list. Right? Perfect. So if answer is equals to false, then we have to just break, right? And let's take a flag. Let's flag equals to true, and we make it here false. Flag equals to false, right? Now if if flag if flag, then we have to print the color for int equals to 0, I less than, and I would say the tape see out color of I. Perfect. And let's make it, and as we have to print possible, see out impossible. Perfect. So this is the code, and let's make the DFS function. Full DFS, in which we have node, and we have color, print color, and we have adjacency list, and we have int and color. Perfect. If color of node, let's first color it. Color of node is equals to C, and then we have to, what we have to do, we have to do call DFS on adjacent node, right? Int adjacent node and adjacent list of add node, and then if color of adjacent node is equals to minus 1, then what we have to do, we have to call DFS. Bool DFS is equal bool, let's suppose answer is equals to DFS of adjacent node and color adjacent list and color, right? And we have to color it with 3 minus c, right? 3 minus c. Why? Because if it is 1, then we try to color it with 2, right? In the team 2, there is two teams, team 1 and team 2, right? Now if answer is equals to false, then we have to just return false, right? And else if color of adjacent node is equals to the color itself, then we have to return false. Right? Otherwise, we have to return true. Perfect. So this is the code. Let's try to run it. Let me check it once. Int and m. Perfect. Perfect. Let's try to run it. There is some mistake. Yes. I color adjacent node. Oh, we pass it differently. First is adjacent node and then color it. And here it is correct. Yes, correct. Now let's try to run it again. Yes, it gives us the right answer. That is 1, 2, 2, 1, 2. Right. The time complexity of this code would be n plus 1. This is the time complexity of the DFS. And the space we are using uh, of vector color of size n. And the overall space complexity would be n plus n, but we are using, but for the solution, we are using n, right? So this is the space and time complexity. I hope you understood. If it is not the case, comment it down. I try to resolve it out. Thank you.